Hi everyone. My name is Amit, and I'm a product manager at Pivotal working on Cloud Foundry. And I'm going to talk to you today about CI and CD for CF. The original title talk was how Cloud Foundry CI'd, and I figured I'd throw CD in there for fun. So what is CI? Let's define some terms. CI is you have a bunch of teams working on different parts of the code, and you're continuously integrating all these things together and then running them through a build which either goes green or red. And historically this was meant to prevent what would happen where people would work on a different branch of the code for months and then try to bring it back together, before they were trying to ship, and you'd have merge hell. So the idea was to continuously integrate the code. Nowadays, most of the focus is actually on the build part and running the tests. So people often commit to the same code base, but the big deal is running your tests continuously and constantly knowing, is it green or is it red? CD, also known as continuous delivery, I actually like to talk about continuous deliverability, because continuous deliverability is that code that you integrate and build. Once it goes green, the business can decide whether they want to deliver it to customers or not. It may not always make the most business sense to constantly be delivering, but being able to decide is what's valuable. What is Cloud Foundry? So Cloud Foundry, I assume most people have some idea, but you've got developers building applications and pushing it to this platform, and the platform is running it for you. And in the meantime, end users are on their computers, on their devices, and they can connect to your applications running on this platform. And the platform is the thing in the middle, allowing developers to just push their apps and allowing users to enjoy the apps that you're pushing. So what is the goal? Why does CF need CI and CD? Because we want to ship CF with speed and confidence. One of the teams I work with, the main goal is to ship the open source Cloud Foundry release constantly. And it's a big, complicated thing, as you can imagine. And so being able to do this with speed and confidence is crucial for us. And of those two things, speed and confidence is the one I want to highlight in this talk. And moreover, what I want to highlight is that this is a human problem. It's not largely a technological problem, right? You can think of it as perhaps a cultural problem, but really it's a human problem. It's humans who need confidence that they can ship their code, because you have a developer sitting there and they have all sorts of questions. Is this gonna break our code? Is this gonna confuse my teammates? Are they even gonna know? Are they gonna understand or like the code I just pushed? Is this gonna break the build? Or is this command I'm about to run gonna actually delete the entire CI server? That could happen. What about if you're working in a microservices architecture or service-oriented architecture, or a complex Bosch deployment like Cloud Foundry? Am I gonna break the communication between my component and another component? Am I gonna break the integration with another component, right? Another team? Am I going to delete some important data by doing what I'm about to do? Am I going to take down prod? That's my graphic for prod, just because that's what CF was in the previous slide. Is this going to take down prod? Am I going to leak a credential or introduce some security vulnerability? Am I even building what the PM asked for? Is my feature going to get rejected? Am I building the right thing? Am I building what the user asked for, or what a user even wants? So maybe there's a big gap between what the PM said we need to build and what the users actually want, right? So all these things, anybody who cares about what they're building and how they're working on it is going to be worried about all these things. And you want the confidence to not have to worry about all these things. And good CI is a necessary condition for confidence. You want to have automated, comprehensible tests. You want them automated because you want to be able to run them whenever. You want to know that they're run in a consistent manner. You want them to be comprehensive. You want them to cover as much as they can about your product surface area and catching your regressions. And comprehensible. You should be able to look at it and, as a human, read it and understand and trust that the tests are going to give you that confidence, right? If you can't understand your tests, how can they give you confidence? And likewise, your CI pipelines need to be reproducible, right? That image in the previous one where you're worried you're going to delete your whole CI server, you need to be able to reproduce your whole pipeline and your whole CI, right? It can't, if that's a snowflake, then that's going to be a constant source of stress. It should be reusable. It should be stateless. You don't want your tests passing because there happens to be this thing on your Jenkins box that just makes it work, and then the next time, you lose your Jenkins box and you bring it back and you don't have the right version of XYZ installed and your tests don't pass anymore, right? And then you've got to ship a CVE and your Jenkins is dead, and then what do you do, right? A CVE fix, not ship a CVE. So good CI is necessary, but not sufficient. And so this is why Pivotal practices a lot of our Agile and XP methodologies. And I'm not here to preach any of those things, but this is what works for us. This is what we find is, in addition to good CI, what we need. So pairing. Pairing is a great way to know that your colleagues are going to also understand your code. Product and engineering collaboration, right? I think developers want to have some ownership over what they're building. In addition to that, by having this close collaboration, you know that what you're delivering has a high chance of being accepted by the product manager and ideally accepted by the user. So PM acceptance, right? PM is constantly giving feedback on the stories that, yes, this implements the feature as I wanted it, and small stories, small incremental things that you can do and get feedback on in your CI, get feedback on from your PMs, get feedback on ideally from customers. So for the open source Cloud Foundry team, we have a set of unique challenges that makes having this sort of confidence difficult. So one of those things is, Schaefer is going to kill me, but it's a PaaS app. It's a platform as a service as a product, right? Because we take this platform as a service, Cloud Foundry, and then we bundle it together for it as a product for other people to then use it whenever they want, on whatever version they want, and upgrade between, in theory, whatever versions they want, to offer that as a service to their users. So Pivotal Web Services is Pivotal's hosted offering of Cloud Foundry, and they are on a very fast cadence. Pretty much as soon as we cut a new open source release, that's up, the Cloud Ops team is pushing that up to prod. Pivotal Elastic Runtime, supports large enterprises who want much longer term support and expect to be able to be on like last year's Cloud Foundry and then upgrade to this year's Cloud Foundry. So we have to support that use case as well. And then there's a whole Cloud Foundry Foundation, so it's not just Pivotal. Many, many large organizations have bet big on Cloud Foundry, IBM, HP, GE, et cetera. And they all need to be able to use these open source bits and deploy them and have them work for them too, right? So there are a lot of stakeholders and a lot of different kinds of stakeholders. It's a distributed system, so that just adds to the complexity in countless ways I don't need to go into. And it's a distributed team. So Cloud Foundry currently consists of about 40 or more teams across at least 7 time zones and 8 different companies at least contributing to it. Around 15% of the contributions to the open source Cloud Foundry are not even Pivotal. So you have to herd all these cats, and they have, not everybody has the exact same incentives necessarily, or the same understandings of how we test and all that sort of thing. So on the previous slide, I kind of skipped over it, but your CI being reusable is really important for it to be reusable across all these different time zones and teams and companies. So let me give you a little overview of how CF is CI'd, and then a little bit more of a deep dive. And then I'll finish with some examples of how our CI has sort of, the way we've done it and the way we've sort of tried to tackle these goals and how they've actually saved us in the real world. So the overview is Cloud Foundry is this big release that represents the whole platform, but it consists of many different moving pieces, right? There's UAA that provides identity and authentication. There's the routing tier. There's the API, cloud controller. There's all the build packs. There's the rootfs. There's a bunch of internal infrastructural components, so NATs, the message bus, console for service discovery and distributed locks, etcd for ephemeral key value store. There's a MySQL database. And then there's the whole Diego runtime, so there's a scheduler, container runtime, et cetera. So there's all these different pieces, and all these different teams have their own pipeline. So they're able to run their own tests in their own pipeline. And then we bring them together. So we bring all that together, and then there's an integration pipeline where we deploy and test the whole thing, the whole of Cloud Foundry. And then that eventually turns into an official Cloud Foundry Foundation approved release. So we're on version like 240 right now, for example. Maybe 241 if I get some more thumbs up in the next 10 minutes. So some of the key tools that we have at our disposal that allow us to do things this way. I mean, this high-level picture, anybody can, at a high level, implement this, but the details matter. And there's some very important things, tools that we use that really make this possible. So number one is Bosch. Bosch is, I wrote here, it's a compiler for distributed systems. It's more than that. It's a tool chain for packaging software, distributing it in a way that's IaaS agnostic, deploying software, managing large distributed deployments, doing upgrades, all that sort of thing. But one thing that it does, of those many things that it does, one of the things is that when you build a Bosch release, that in itself is almost like a form of compiling your distributed system. If you can build the release, you know that a lot of your packaging scripts and all that stuff are right, just by running that command. And if you can do a Bosch deploy, before you even exercise the system, if you can Bosch deploy, that tells you a lot about the fact that your startup scripts will run your processes correctly, and how you configure things to talk to each other. Does this thing have the right credentials to talk to this database? It's a sanity check that all that works, right? So so that's why I call it a compiler for distributed systems. Consistency between environments, so you can build a Bosch release once upstream, and then pass it downstream and deploy that exact same release to AWS, Azure, GCP, Photon, what have you. And you can deploy it in all sorts of different configurations, just using that one release artifact. And it has a declarative configuration. So being able to look at the configuration and read it and check it in and understand it is crucial. Second key tool is concourse. So concourse itself is Bosch deployed, and that means that among many things, it's really easy we could lose our entire concourse and bring it back, or we can upgrade our concourse every week and it's fine. I remember back in the Jenkins days, having to upgrade Jenkins was a frightful experience. Whereas concourse, some teams go so far as to have their concourse automate the deploying of their own concourse, so they're just automatically on the latest concourse. You may choose to do that or not, but some people go that far. It has an intuitive read-only web UI. So this ties into the next point of declarative configuration. All the configuration is declarative and checked in. There's no clicking around in the UI. There's a single source of truth for what your pipeline does, and anybody can read what that does. And the UI is really intuitive. I could have given an entire talk on concourse, and if there's still time, I'll show you visually what our pipelines look like. But it's night and day. Like sometimes you take for granted, especially if you've been using concourse for a year or two, how nice it is. But if you go back to something that doesn't have this UI, where you can't just look at it and understand how does your code go through the pipeline from commit to final release, it's really amazing. And the third key tool is the CATs, the Cloud Foundry acceptance test. So this is a high-level acceptance suite for all the features in Cloud Foundry. It's ideally, I mean, it's meant to be very comprehensible. So end users and developers alike can read it and understand what's supposed to be done. Right? So everyone can trust that the tests are really making sure that Cloud Foundry works. And it's a shareable thing. All the development teams can share this acceptance test and run it in their own environments. So let me dive into one of the component pipelines. So like I said, the big picture was a bunch of different components are contributing their pieces, building them, testing them, and then those get integrated into a integration pipeline. So let me dive into what one of those component pipelines look like. So for example, the routing release. So the routing release consists of several components, most notably the Go router. So the Go router component in Cloud Foundry is responsible for basically maintaining a route table between, my app.cfapps.io to a bunch of IPs and ports representing your containers running your applications wherever they may be. It has several other components like a TCP router, which does the same thing for TCP routes. So it maps, an external port to an internal IP and port. So the first step is unit tests. So just the code itself, did the unit test pass? That's the first thing you want to do in your pipeline. The next thing is build a Bosch release. So that sort of compiler for your distributed system thing, like does the distributed release aspect of it build? And if it does, deploy that. So deploy that to the test environment. And then run they call it the RATs, the routing acceptance tests. So just the routing components themselves, independent of the rest of Cloud Foundry, have their own APIs and feature sets that can be exercised at a high sort of behavior level. So they run those tests. Next, they take the rest of Cloud Foundry, sort of the last known good combination of all the bits in Cloud Foundry, together with their latest routing release code, and they build that into a Bosch release of the whole Cloud Foundry. And then they deploy that to the test environment, and then they run the CATs. So every team is making sure that their latest change to their bits works with the last known good collection of everything else in Cloud Foundry. And this is not specific to Cloud Foundry, right? This is a potential approach you might want to take to your own microservices deployments, right? You want everybody to be able to deploy individually, but then there's always the question of how do I bring them together and make sure they work together. So this is one potential way of going about it. Now, if that all works, then it's deployed to the acceptance environment, and the PM manually does acceptance. So they manually exercise the features that they had asked for and to validate that they really do work, or manually or however a user would. So if an end user would write a script against it, they write a script against it, right? How would a user use this? And if that's accepted, then they can ship the routing release off to the world. And so there's a good routing release out there in the world. The next step is the integration pipeline. And it picks up where the other pipelines leave off. So there's a routing release and an identity release and a Logarithm release and a Postgres release, and all these things have been shipped off to the world because they've passed their own pipelines. For whatever that team or that component feels it needs to be confident that it's a good release, that's out there in the world. So now the integration pipeline consumes them, and it constructs a manifest saying, here are all the things I'm about to deploy together. And then we deploy them to multiple different configurations. So there's sort of a combinatorial explosion of configurations you can think of, right? Every IaaS you care about. So for example, Garden as an IaaS, and vSphere and AWS, and so on. What about multi-AZ versus single AZ? What about internet access versus no internet access? What about a fresh deploy versus a rolling upgrade? So there's all sorts of different permutations that you might want to try to deploy in. We do that. We run the acceptance test against all of those, and then we fan back in. If those are all good, then we certify that manifest as that manifest, which sort of lists all the releases that work together. We say that they're good, and then we ask the project leads within the foundation responsible for different components in Cloud Foundry, does this combination of things work for you? This thing that you shipped, was that good, or have you detected any regression since then, or whatever? There's an open public sign-off process, and if there's a public sign-off, then we ship it. So with the last few minutes, let me go over a couple examples of how our CI pipeline has saved us in the real world. So the first example here is of a CVE plus a major regression at the same time. A CVE fix and a separate major regression at the same time. So the first thing that happened was a security vulnerability was identified in the UAA identity code. It was quickly fixed by the identity team. They built an identity Bosch release, and it went through all these pipelines that I mentioned, and we eventually had a new version of an official Cloud Foundry release. And that's when the clock starts ticking, because that's when we tell the like the CTO of the foundation that, hey, this critical CVE that's currently embargoed, we have a fix, it's in a release. You can tell all the foundation members that they should be ready, in 48 hours at this time on this day to ship this to all their customers, because at that point it's a potential zero-day exploit, right? So we want to be able to ship it right away. So this is when the clock starts ticking. Shortly after that, the Pivotal Cloud Ops team deploys to Pivotal Web Services, and the deployment breaks. So for all the pipelines that we have, there was something that we didn't catch. And what we didn't catch was something which, when you deploy it at PDUB scale, something doesn't work. Right? What we found, there was a performance regression in the Metron component, one of the components of the metrics and logaggregator subsystem. So, all right, so there's this thing, clock's ticking, PDUB is kind of broken, and there's a 0 day on our hands. So, I mentioned earlier, collaboration is really key for confidence, and that's probably more important than all these pipelines, or equally as important. Because the Cloud Ops team could directly open a channel with the logaggregator team and say, we had this issue, and they could understand it and fix it, run it through their pipelines, have that run through the integration pipelines, and within less than 48 hours, there was another official CF release cut, which worked on PDUBs. And then we could announce to the world, here's a release, it fixes this CVE, and by the way, it doesn't have a performance regression in it. And what's really crucial about this is just to keep in mind that with such a large, complicated project, with so many people and teams and time zones and companies involved, there was almost no stress in this situation. We were able to do this very fast. Most people probably didn't even know anything was going on, and nobody needed to. Right? The system just worked. Everyone had empathy. That was also key, right? Like the Cloud Ops developer empathy was there. It's like, oh, you broke our stuff, you fix it now. It's like, we've got this problem to fix, let's fix it. And everybody worked together to fix it. PDUBs deployed their stuff very soon after, so we could very quickly get that feedback that the fix did indeed fix things. So we were able to do this with speed and confidence. And the last little example is what happens when you delete CI. So So on one of my teams, we had our concourse, it's all humming along. All of a sudden, unbeknownst to us, it's gone, it's on fire. I noticed the little buckle up, you're in for some turbulence icon on concourse. So like, I haven't seen that before. The team quickly figures out that one of them had accidentally targeted the wrong Bosch director and run Bosch delete. Not a big deal. We redeployed, right? Our deployment was checked in. We just did another Bosch deploy and it was back. The concourse pipeline YAMLs are all checked in. We have a script that iterates through our pipeline YAMLs and just a fly set pipeline. Fly is the command line tool for concourse. And they were all back and the cats were running. And that was it. And it was fast and easy and painless. Nobody sweat at all. And that was that. That's all I have. Thank you. Any questions? Yeah.
So how long, once you get the fix, the CVE and the performance progression, how long does it take to go all the way through?
So it takes probably end to end. If everything passes, like if nothing goes red, something on the order of 4 hours. So this includes deploying a full, like multiple full 30 VM deployments of Cloud Foundry and running a full battery of tests against it. We also have some tests that deploy from scratch. So it tears down the entire environment, spins the whole thing back up, recompiles everything. So yeah, I mean 4, I think, depending on where you're coming from, could sound like a long time or a short time, but for something like this, it's quite fast. Yep.
Who writes your acceptance tests?
So the acceptance tests, like I pointed out earlier, are shared, and they're written by all the teams contributing to Cloud Foundry. So if the routing team is adding a feature that, especially if it's a feature that's exposed through the platform, like through the CF CLI or the Cloud Foundry API, then they will write out an end-to-end test that drives that. I, as a user, can log in, push an app, bind a route service, for instance, and see that my route service middleware like works, and then tear it down and do all those sorts of things. So the individual teams are responsible for making sure that their high-level acceptance tests are captured in the Cloud Foundry acceptance tests.
So if there's a new feature going out to implement the acceptance test, then you ship that as well as part of it.
Right. So one of the things we're working on right now is something to allow teams to essentially run a branch of their acceptance tests as they push their new code through their pipeline. And as those two things pass, the integration team's pipeline will pick up their new release, and at the same time their branch will get merged into the sort of master of acceptance tests, and that's what will run through the integration pipeline.
And is it part of concourse that you write the acceptance tests on?
So the acceptance tests are just written in a BDD framework called Ginkgo, which was written by Ansi. Ansi, you hopefully heard him speak a couple days ago. So it's a Golang testing framework. If you've ever written RSpec, like in Ruby, or it's heavily inspired by RSpec. So it's a BDD framework, Golang framework that you can use to write your tests. We've written certain like helper packages to drive the CF CLI because most of the acceptance tests involve driving the CF CLI to do certain things. I realize I forgot to answer your question, or repeat your question, which was, does Concourse have built-in stuff for these acceptance tests? And no, the tests are just written in a Go BDD framework. Yeah. Yeah, so the question was, can I show the actual Concourse pipeline? So there's many pipelines, but I'll try to show you one. by the way, all of our pipelines are publicly viewable. So if you get in touch with me, I can give you the URL, but it's runtime.ci.cfapp.com. And so the heart of it is here, generating manifests for AWS, vSphere, and Bosch Lite, then deploying to all these environments, running some smoke tests. So I didn't actually mention this before, but actually one thing that's probably worth highlighting is both in the individual component teams tests and in the integration teams tests, you want to go from small, fast feedback loops to the big, slow ones, right? So like, do your unit tests pass? Does your code compile? Do your unit tests pass? Does your Bosch release build? Can you deploy it? And then maybe smoke tests, like can I push an app to the platform and scale it up and scale it down? If that's good, then run the full battery of acceptance tests that test all the bells and whistles that come with Cloud Foundry. So we have this intermediate phase of smoke tests, which is like if you've totally borked how you've configured it, you'd rather have that 2-minute app push and delete and scale test fail rather than this 40-minute suite that does literally everything. So once that's done, it's promoted to a release candidate branch. And then the release candidate branch, let me show you another thing. So every once in a while, I will click this button that says announce the release candidate, and this will create a comment on a GitHub issue that will ping all the foundation members to give a thumbs up or thumbs down on it. Let's see, if it's, if everything's thumbs up, maybe we can cut a release on stage. I bet it's not though. So the Java build pack team hasn't given their thumbs up yet, and the identity team and the routing team haven't given their thumbs up yet, but this is the SHA that anybody can look at and decide whether it's good for them. And if it's good for them, then I promote the branch, and then it automates building the final Bosch release and doing all the Boshy things it needs to do. Yeah? Yeah, we do. So one thing you can maybe see here is for example, the vSphere stem cell. If you're familiar with concourse, this represents a resource, and this thick line represents that it will trigger a build. So if there's a new stem cell, it'll redeploy. So we're always on the latest stem cell. Yeah.
This looks complicated. Do you have any tests that make sure the pipeline looks right?
That's a very good question. So the question was, this looks complicated. Do we have any tests that make sure that the pipeline is correct? That's a good question. The answer is no. It is complicated. I would say, so my current thinking on this question is it's all declarative. So if you look at how this pipeline is configured, you can look at it and reason about it, and you can, so you can see, oh, this thing is triggered off this thing. Is that correct or not? Now you could ask the question like, okay, I could manually look at it, but what happens when I forget to look at it, right? So do I want to automate a test for that? What I worry about there is that because it's this straightforward declarative YAML, any test you could write for it, I would imagine would just be equally or more complex than the pipeline itself. I'd be more worried about the test being wrong than the pipeline being wrong. But that doesn't mean that it's not a valid concern or that I'm right. Maybe there is a better way, but it's a totally valid question. Okay, I think we're done. I'm happy to continue to answer questions, so feel free to come up. Thank you.